an expression for gravitational potential energy at any point in gravitational field. This is a question. Earth, this is radius of Earth, this is observation point at height h. Derive an expression for gravitational potential energy at any point in gravitational. Around Earth there is gravitational field. यहाँ कहीं तो हम मास लटम मास ऑफ अर्थ कैपिटल एम आर रेडियस पी पी capital P is observation point. At height h from Earth's surface. What is gravitational potential energy? Work done by any mass from infinity to this point. So there is no direct method. So work from this to this. A to B. Take any mass. Take mass M from A to B in gravitational field. That is AB dx. This distance say x and OA is x. Now work done from A to B, that is dW f dx. dW f, here f is g m by x square into dx. This is f at this point, hence work done from infinity to P integrate it, constant outside, minus 2 dx. X is variable, this is x, from where the mass is coming, x, infinite, to p, r plus h, gmm, add 1 to power, divide by same power, infinity, r plus h, minus outside, gmm, 1 by x, infinity, r plus h, gmm, value of x is this, r plus h, minus value of x is this, infinity, gmm, r plus h. This is work. Hence, gravitational potential energy at P, that is U, gmm, r plus h, special case, at surface, r plus h becomes r, therefore u minus gmm by r. This is special case, say first. Second special case, energy difference between 2 points, that is at height h and on surface energy difference U1 minus U2, U1 gmm r plus h at a height minus U2 gmm R on surface. So this is G, M common, R also common. Minus is there. 1 H by R. Minus also common. Minus 1 by R. It is G M R. It is 1 plus H by R power minus 1. Take upward. R is common, so it is 1. 1 by 1 or 1. G M by R binomial. Multiply this with this. If this is 1, this is small, multiply this. H by R minus 1 minus plus minus 1 with plus 1. So it comes out to be G M by R square. This is fifth. But G is what? Gm by R square. G acceleration due to gravity. So it comes out. H is also there. G M H. Find expression for maximum height reached by object if it is projected upward with a velocity. This is a problem. From Earth's surface or any planet may be there. This is Earth, radius, mass, this is that object, this is say velocity, and this is maximum height. H. let R radius of earth, M mass of earth, H maximum height reached by object, V velocity from ground. How to solve this? What is total energy here in this object, and what is total energy here? Equal law of conservation of energy again. What is total energy here of this object, and what is total energy here of this object when it reaches here? Total energy of object at a surface is what? Potential energy and kinetic energy. Potential energy means gravitational potential energy. We have done, it is G M by R. This is the potential energy in this object here at this point, and it is half mv square. This is kinetic energy given to this object. Total energy of object at P, that is what? Potential energy plus kinetic energy. Potential energy minus G M R plus H, and kinetic energy is 0. Why? At maximum height the velocity becomes 0. Minus G M R plus H from first and second law of conservation of energy. They are equal. Minus G M R plus half mv square minus G M R plus H. Take this to this side. Half mv square G M by R minus G M R plus H. M common, small m cancels out. Half V square, G common, M common, R common, it is 1 minus 1. R common, so 1 plus H by R. It is GM R, 1 minus 1 plus H by R, power becomes minus 1. If you take here, so it is GMR 1 minus H by R. Multiply this binomial theorem, or it is GMR 1 minus 1 plus H by R, or V square to GM R into H by R, or H V square, take this to this side, R square to GM. This is my height reached by object, maximum height reached. Two uniform solid sphere of equal radii r, masses m, 4m. These are two solid spheres, radii r each, masses m, 4m, have their centers separated by distance 6r as shown. Equal radii, solid spheres are there, equal radii, masses m, 4m, centers separated by 6r as shown. The sphere held fixed, these are fixed. A particle of mass m, this is a particle, the mass is m, is projected from mass capital M. यहाँ से प्रोजेक्ट किया कैपिटल एम से डायरेक्टली टुवर्ड सेंटर ऑफ अदर स्फीयर इधर. फाइंड मिनिमम स्पीड, लेट v is the speed, that minimum speed so as it reaches to sphere. How to do it? Let this be neutral point. If the particle reaches here only, then as it is having energy velocity, so it crosses the mark P. Now this sphere will attract. So this velocity should be only to reach the particle here. As particle reaches here, velocity may zero. At neutral point, force of attraction equal and opposite. But this sphere will attract it. But as it just crosses, because of velocity, velocity decreases, goes on decreasing. Here it is zero, but it will just cross it. So this velocity should only to reach neutral point, and this object will reach automatically to this sphere. So first is find this neutral point. Let P is neutral point. And OP is x. So this distance now 6r minus x. The particle is here, force G m by x square. If the particle is here, force between this and this, G 4m m mm. This is 4m m by 6r minus x whole square. The capital M, small m, z. Take square root. 1 by x, 2 by 6r minus x. 6r minus x is 2x. 3x is 6r, or x comes out to be 2r. Now, according to law of conservation of energy, at this point energy, due to this sphere, this is potential energy. Here, energy in this object, due to this, it is imparted velocity, so kinetic energy. Energy due to this, G 4 capital M small m, this distance, due to this distance, this is r, this was 6r, so it is 5r. Energy due to this sphere, potential, kinetic, due to this distance is what? 5r, is equal to, here the velocity becomes 0, so no kinetic energy. Energy due to this, here at P, energy due to this, it is minus G capital M small m by x. Here P distance is x, and what is x? It is 2r, minus, due to this, G 4m m, this distance, it is 4r. If this is 2r, what is this? This is 4r. This goes with this. Half mv square. Take this side. 4 m G 5r G m 2r. M, small m, common cancels out. V square. It is G capital M by R. 4 by 5. It is what? 1 by 2. G M R LCM 10. 8 minus 5. It is half V square GM R 3 by 10 or V square. It goes to 5. V square 3 by 5 gm by r, or V is 3 by 5 gm by r root. So this is what minimum velocity given to this mass to reach. Another question. Two stars each of solar mass kg. Two stars of each of solar mass, this are approaching each other for head-on collision. When they are at a distance kilometer, their speed negligible. With what speed they collide? With what speed they collide? If radius of each star ten raised to power 4 kilometer. These are two stars. Their distance raised to power 9 kilometer. So this much meter. Here velocity is 0. Now they collide. This is collision. So this distance capital R. This distance also capital R, means distance here between them is this. This is the velocity of collision, and we have to find this velocity. Again, they are at this distance, then velocity is negligible. Now they collide, then they will be at this distance 2r, because r is radius of each, and there is velocity of collision. So here the energy is only potential, here it is potential plus kinetic, and this r is 10 raised to power 4 kilometer. Total energy at distance small r, it is G M by small r with minus. Total energy when collide it is minus G M to capital R plus half mv square mv square, where what is this v? Velocity of collision. So half mv square minus gm by r is equal to gm by small r. This m, capital M was there. This was also capital M, no small m. Cancel out, or v square. Take this to this side. GMR minus GM small r. G common, M common, R, GM common. 1 by r small r. Suppose it was conceptual, then we can find velocity, take under root. Now it is a numerical. G minus 11 capital M to 30 by 1 by R. This was R. Minus 1 by smaller. .67 into 2 plus 19 . Take out common. 10 raised to power 4, 10 raised to power 3. It is 1. It is 1 by something. 10 raised to power 5. It is 6.67 into 2 into 7, 10 raised to power 12. It is 1. Neglect 1 by as very small. Ten raised to power 12. V 10 raised to power 6. It is 37 watt meter per second.